All right, so this is problem number 12. Let me show it again. All right, and which function's graph has a vertex at 3, 5 and contains the point -255? Of course, one approach you could take with this right off the bat, if you want to take the time, is to graph all 4 of these and see which one of these has a vertex at 3, 5. And then out of the ones that have a vertex of 3, 5, then see if they have this point. So that's one approach you could do. Another approach is, and this is the way in which we taught it, is that you would use these two information, use these 2 points and the vertex formula to find out which one is the correct answer. So that's the approach I'm going to take here. So which function, so we're looking for a graph that has a vertex of 3 and 5 and contains the point -255. So here's the point, -255, and here's the vertex, 3 and 5. We'll need the vertex form, and it helps if you label the points too. The point gives us the x and the y value. The vertex gives us the horizontal shift, or the h value, and the vertical shift. That's what the vertex gives you. So if we substitute those values into this equation, we'll get something that looks like this. Put the 55 in for y, we put the -2 in for x, and we put a -3, actually we put a +3 in for h, but because there's a minus sign in front of the h, we have to leave that minus there. And then we put in a k, 5 for k. All right, so we simplify. -2 minus 3 is a -5. A -5 squared. Oh, by the way, we don't know what a is, so we have to leave that. Once we find what a is, we're done with this problem. So -2 minus -3 is 5. But 5 squared is 25. And that's where that 25 comes from. I bring everything else down. Now let's solve this linear equation for a. We're going to subtract 5 from both sides because we want to isolate the a and get it by itself. Once we do that, we'll get 50. 55 minus 5 is 50. And bring down 25a, of course, the 5 minus 5 is 0, goes away. Additive inverses. Now to get the a by itself, we need to do the opposite of multiplying, which is divide both sides by 25. When we do that, we get an a value of 2. So which one of these equations has an a value of 2? A value of 2. And so if I can go back to my problem, let's see, there we go. Look, which one of these? Choice A has an a value of 1. You're looking at what's in front of x squared. That's the a value. B has an a value of 2. C has an a value of -2. And D has an a value of 4. So the correct answer is B. B has an a value of 2. So if you graph that function, which I did in the Desmos as a check, here's the function. This is B. I checked it. And I also graphed the point -255. And I graphed the point 3, 5. 3, 5 is the vertex. 2, -255 was the other point. So